Good evening, sir.
Yeah, good evening. Yeah, wait for a few minutes. Let them join.
Okay, sir.
Hi, sir.
Fine. So let's wait for a few minutes. Let people join. So meanwhile, you have any questions? Did you go through
Sir,
the
can you just say that discriminant rule, sir?
which one?
The cross product discriminant that take a method.
Okay, fine. And right, did you go through the list of what I sent as the quiz? List of concepts. I sent in WhatsApp.
Yes, sir.
So go through that. So it's only those concepts you will need for this particular test. Okay, that's why I opened here. I'll just show here. This one. You can see the screen, right?
Yes, sir.
Okay. So just before other people come, let me just start. So cross product is A cross B, right? And you just have to use A cross B, okay, and A can have components AX I cap plus B. Sorry, hold on, someone is calling me. Hello. Yeah, good evening. Okay. Oh, but you have to have Zoom. No, you just have to click that link. It's Zoom is no. See, that is one option, but other option is if you go for the web-based this thing, you don't need the Zoom app. Can you just you're using laptop or something else? Okay. So what does it say when you click that link? What does it say? I just click that, no? You just try. Let me know. Yeah. Yeah. So you have to join, no? Yes, sir. So can you just tell that to others? Yes, sir. Yeah. So I'm just waiting for people to join. Okay. Yeah, no problem. Thank you. Okay, so white J component, Vy, and then Z component K cap, right? So this cross is really B, Bx, By, Bz, I, J, K. So you just have to use this result that I cap cross I cap is what is this one? I cross I and I cross J and then I cross K. So by definition, A cross B is A into B into sine theta. So there are two same vectors, then theta is 0. So I cross I is 0. Okay, and I cross j will be sine 90. Okay, so it will be 1, and the direction will be k cap. Direction is given by the right hand thumb rule. I cross k is again, I cross k is j cap. The magnitude is 1, and the direction will be j cap. Actually, minus j cap. Right. So if you use this thing, I can cross this with this, which will give me 0, and I'll cross this ax with this second term. That will give me ax py, and I cross j will be k cap. So if I cross I with this k, it will give me ax bz into I cross k will be minus j cap. So this I crossed with all the terms. I can cross this with all the three terms. So I'll get 2 terms here. Okay, and k cap cross with the 3 of them will give me 2 more terms. So basically there's 6 terms. Cross product the first time we learned cross product this, I think chapter 7 only. See, this is A cross B, right? And in component form, A is this one. Ax component, Ax I cap plus A by J cap plus A z K cap. Similarly, B components are this one. So when crossing this thing, I just use this result. I cross I will give me 0. I cross I is 0, J cross J is 0, K cross K is 0, because A cross B is A into B into sine theta. Two same vectors, so theta is 0. So only the cross terms will give me something. I cross J is K. Okay, this is given by the right hand screw rule or right hand thumb rule. This one. A cross B is, I have to rotate this screw from first to the second vector. So the screw will progress in the upward direction. Okay, you want to comfort with this screw, use the right hand. The fingers will curl from the first vector to the second vector. The thumb will give me the direction of the product. Okay, so using that, I'll get I cross GS K. And then J cross K as I, and K cross I as J. Okay, so using these things, I can, when I cross this thing, I cross I will give me 0. So I cross J will give me K, and I cross K will give me J. So K and J. Okay, similarly, this term will give me J cross I and then J cross K. J cross J is 0. So this cross with this one will give me these 2 terms. Okay, similarly, K cross with these 3 terms will give me 2 terms. That is these 2 terms. So I can, after that, I can combine I terms, J terms, and K terms. So I will come out with this one. So this can write in the determinant form. Okay, when I expand this determinant, I'll get I cap into A by BZ minus B by AZ. So this thing is, whole thing is written in the compact form like this. So which is J cap, J into, you can either you can do like this or I can do like this one, AZ into BX minus AX into BZ. And then K is this one, AY, AX BY minus BX AY. Okay, so corresponding component form is this one, and this thing you can write in compactly as this determinant form. So the way to expand this determinant is, when I expand this determinant, I'll get this one. So I cap into this one, which is this minus this. J cap into this minus this. K cap into this minus this. So Tarun, is it clear? Cross product.
Yes, sir. But then when we are doing the right hand thumb rule, should
Yeah.
the vectors be tail to tail always?
Yes. Tail of the 2 vectors should meet.
So if we keep it in tail head formation, it won't come correctly.
Yeah, obviously.
Oh, okay, sir. Got it, sir.
So tail of these 2 vectors should meet. Okay, and then this forefinger should go in the direction from first vector to second vector. Here, A is the first vector, B is the second vector. The finger should go from A to B. So the thumb will give me the direction of the product C. Or if you have a comfortable screw, if you rotate the screw from A to B, the screw will progress in the upward direction. So A cross B is defined as AB sin theta, and the direction is given by this thumb rule. Like A dot B is defined as A into B into cos theta. Cross product A cross B is defined as A into B into sin theta. So the dot product will be 0 when they are perpendicular. Cross product will be 0 when they are parallel or anti-parallel. Because anti-parallel means it's 180 degrees. Sin 180 is also 0. Okay, so for the people who joined in late, just there was some doubt. A cross B in terms of determinant form. Okay, so A cross B I can write as AS in components. X component, Y component, J component, I cap, J cap, K cap. And the second vector B is again components will be Bx, By, Bz. Okay, so I can expand this product. So I will cross with I, which is 0, and I will cross with J to give me K, and I will cross with K to give me J or minus J. Okay, so this first term multiplying these 3 will give me 2 terms. Similarly, the second term, okay, this multiplied with I cap will give me K cap, and this multiplied with K cap will give me J cap. But J cap cross J cap will give me 0. So even the second will give me 2 terms. And the third will also give me 2 terms, so it will give me 6 terms. That's what I say. There are 6 terms, right? In this cross. Okay, and this thing can be written as a determinant like this. So you should know how to expand the determinant. So you get expanded I into this one, that will be AY BZ minus A BY AZ. That's what is here. I cap. And the second one, J cap into these two. So it will be AZ BX minus AX BY. And then K cap, this one, AX into BY minus BX into AZ. Okay, so that is the only thing I did because someone asked a doubt. So now I'll go to the concept which you're supposed to know for the test. Is it okay? Yeah, anyone?
Okay, sir.
Yeah. So,
Yes, sir.
yeah. Doubt? Okay. So Pythagoras theorem in 3D mean so this is my coordinate system, say X, Y, Z, and I have a point here whose coordinates are say X1, Y1, comma Z1. So the distance of this point from the origin, okay, that is given as square root of X1 square plus Y1 square plus Z1 square. Okay, so this thing I can XY plane, right? So this coordinate from this plane, drop of perpendicular to this XY plane will be somewhere here. The coordinate of this point will be X1, comma Y1. So this distance is by Pythagoras theorem 2D. It will be square root of X1 square plus Y1 square. Now, since there is a perpendicular drop to this point, so this angle is 90 degrees. So in this triangle, if I again apply Pythagoras theorem, will be this square plus this square, and this is distance is Y Z1. So in this right angle triangle, again, if you apply Pythagoras theorem, this square plus this square, that will be this one. So it is just too confusing. Just remember this result. Distance of a point X1, Y1, Z1 from the origin is square root of x1 square plus y1 square plus z1 square. So this is Pythagoras theorem in 3D. Okay, with this, this is enough for this right now. And for a circular motion, say mass moving in a circular path. There is a center here, and there's a mass which is moving in a circular path of radius r. Even if we take uniform circular motion, that means that the velocity magnitude is same. Like everywhere the velocity vector length will be same, but the direction is changing. Okay, so this uniform circular motion where the magnitude of the velocity is constant, and also the omega, the rate at which the angle is covered, that's also constant. So since the velocity direction is changing, there is some force acting perpendicular to it. Okay, and this force, centripetal force, and the corresponding acceleration AC is this centripetal force divided by the mass of this object. And this is turned out to be v square, which is the linear speed, divided by the radius of this circular path. And this is also written as omega square r, because the relation between v and omega is v equal to omega into r. This was circular motion, and for simplicity, let me assume it's uniform circular motion. So this relation we can get by taking this time period t, which is the time to complete one full circle, that I can write as the circumference of the circle divided by the linear speed v, and it's also the angular displacement of the full circle when I make a complete, which is 2 pi, given the angular speed omega. Omega is the angular speed, which is how fast I cover an angle in a given time. So for a complete circle, this delta theta is 2 pi, and the amount of time taken will be capital T. So from that I can get capital T as delta theta by omega for a complete circle, that is 2 pi. So here 2 pi will cancel. So I get v equal to omega into r. So this is a basic relation for circular motion. So using this from here, I can get this one. So either centripetal acceleration, either remember in terms of v square by r or omega square into r. Okay, so this centripetal acceleration just changing the direction of the velocity. Magnitude is same. Magnitude of the velocity vector is same everywhere. Only the direction is changing. Okay, and since v is a vector, even if one of them changes, v is a vector that has got both direction and magnitude. So even if one of them is changing, there is changing velocity, and acceleration is d by dt of the velocity vector. Even the magnitude is same, since the direction is changing, this is not equal to 0. And that is equal to v square by r for a circular motion, uniform circular motion. So just remember this one, for a uniform circular motion, the centripetal axis, centripetal means towards the center, centripetal. Okay, axis towards the center, that's v square by r, and also equal to omega square by r, since v and omega are related as v equal to omega into r. Okay, any questions?
No, sir.
Okay. Next are the equations of motion. So this third straight line motion chapter. So how many equations of motions are there? 3 of them, right? V equal to U plus AT. Second one is S equal to UT plus half AT square. And the third one is V square equal to U square plus 2AS. So basically there are how many variables? U, V, AT,
Sir?
here. Yeah.
Sir, Sanjeev has a doubt, it seems.
Okay. Yeah, unmute your mic.
Sir. Yes, sir. Can you hear me, sir?
Sorry.
Can you hear me, sir?
Yeah.
Sir, how we got in omega, sir, that centripetal acceleration?
Right now, I think we can assume this result. Okay. So right now, I don't have time to derive this one. Just use this result. It's like a formula. Okay. The only
Okay.
property of this is velocity is a vector. here the magnitude of the velocity vector is not changing, but the direction is changing. So there is a force like this towards the center, which will like tilt the arrow. Okay. If there is an
Okay, sir.
acceleration tangential, then the length of the vector will change. Here, the length of the vector is not changing, only the direction is changing. So some force is pulling it towards the center. Okay.
Okay, sir.
That acceleration corresponding with the force, which is this force by mass, is v square by r. So take this as a formula for the time being.
Okay, sir.
Okay.
Thank you, sir.
Yeah. So equations of motion. So the first one, actually the variables are v, u, at. So 4 variables are from here, and fifth one is s. Okay. So today there are 5 variables. So if 4 are given, I can find the fifth one. So in the problem, if v is known, u is known, s is known, I can find a using this last one. Right? Because v is known, u is known, s is known, only unknown is a. Okay. So if time is known and v and u are known, I can find acceleration is this one. Okay. Similarly, if s is known and u is known, but not the final velocity, and a is known, or if time is known, I can find a. Okay. So basically, there are 5 variables depending on what is known and what is unknown. I have to choose which equation to use to solve the problem. Okay. And these equations are valid for one particular condition, that is a is constant or a is uniform. Okay. Example of such a force is gravitational force. Since the Earth, if the distance is not very large, the acceleration which is due to the Earth attraction, which is g, is constant and uniform. So for this motion and the gravity, I can use these equations. Okay, so right, so I have to remember these equations. So spring, the properties, if I stretch it or compress it by an amount x, it will have a if you take a spring, it will have a natural length, say L0. So from this natural length, suppose I stretch it by an amount x, then there will be a force developed in it, which will try to bring it back to its original position. So this force, and this force is given as k into x. Okay, x is the amount of extension. Okay, suppose L0 is say 1 meter, and after extending it has become 1.5 meter. In that case, x is the 0.5 meter, not 1.5, because x is the extension from the natural length. Okay. So and similarly, if I compress it, okay, to 0.5 meter, so that this becomes 0.5 meter. Then again, this produces a force, but this time the force will be towards right, to bring it back to the original position. So this force is k into x, same k into x, but x are put as 0.5. And in the formula in the book, they would have put as minus sign here. Okay, just to convey the fact that when x is positive, like when you stretch it, x is positive, right? But the force is opposite direction. So that is conveyed with negative sign. And similarly here, the x is negative because I have compressed it. So in this case, x is negative. So the force is towards right. So here x is negative and the force is towards right. So just to convey that fact, they have put a minus sign here. But the physical meaning of this negative sign is the force is towards the equilibrium position. So here I stretch it away from the equilibrium position. If you go to the equilibrium position, I have to go force will be towards left. Here I have compressed it, so I have moved towards left from the equilibrium position. So the force will be towards right to bring it back to the equilibrium position. So negative sign you can put it later, but the magnitude of the force is k into x. Okay, so whenever I do a work on the system, when you do work on the system, the potentiality of the system or the energy of the system will go up. Okay, when work is done by the system, the energy of the or the potential of the system will go down. It is losing energy, right? So here to compress it or stretch it, I have to do work on the system, which is the spring. So that work done is for a small interval will be F into dx. So the compression on the x-axis. and the force is K into X dx. So the total work done to go from X equal to X2, the maximum compression, say some amount, say Xm will be this integral, and this will be K into X squared by 2. So from this, I'll get the potential energy stored in the spring when I compress it by Xm is half K Xm square. So this was there in the book. Concept of potential energy. Here. Okay, so this is spring as a natural length, so the force is 0 because the force Kx is X is the change from the natural length. Right, it's the natural length, so X is 0. So when I try to stretch it, X is positive, but the force is towards the equilibrium position, so Fx is negative. Okay, similarly, when I try to compress it, the force will be towards right. So X is negative because the displacement towards the left and the force is towards the right. So just to convey this fact that the force direction, the displacement direction are opposite, the force they have put as minus Kx. And the magnitude of the force is Kx. So when I stretch, when I compress the spring from the natural length to the maximum value of say Xm, the total work done is integral of dx, and the force is K dx. So if you integrate this one, I'll get the total work done to compress it from 0 to Xm as half K Xm square. So this work done will get stored in the spring as the potential energy. So potential energy stored in the spring is half Kx square. So whenever work is done on the system, its energy will go up. So here I'm doing work on, I'm applying force on the spring to compress it or stretch it. So the system is just the spring, and the external to the system is my hand. So my hand is doing the work of compressing and or stretching. So work is on the system, so potential will go up. Okay. So work is done in compressing or stretching the spring, goes in increasing the potential energy, and the potential energy is half K. This is simple. So for as far as integration is concerned, we should remember this basic formula of the result. Integral of x raised to the power n is the power will go up, sir, and variables dx. So integration with respect to x, so the power of the x will go up by 1, and you get divided by n plus 1, and some constant we get added. So integration is the reverse of differentiation. So if we differentiate both sides with respect to x, because x is the variable of integration with respect to x. So differentiate this when you differentiate the left hand side, dn integral are opposite, so I'll get x raised to the power n. So left side I'll get n raised to the power 1 into x raised. Okay, before this I have to use this formula. D by dx of x raised to the power n is the power of x will go down by 1, and this n will come here. Okay, so this first I have to know this one, this formula, because I'm going to use this thing here. So differentiate both the sides. So differentiating n plus 1, x raised to n plus 1 give me n plus 1 into x raised to the power n using this one. This result. Okay, so divided by this n plus 1. And when you differentiate constant, it is 0. Okay, because derivative in some sense is d by dx of some function of x is slope of f of x curve. So if the function is constant, like c, the value is c, slope is 0. So derivative of a constant function is 0. So if you use that, I'll get this one as 0. So n plus 1 and n plus 1 will cancel. So it is true. So integral of x raised by n is power will go by 1, and you divide by n plus 1. When I differentiate, the power will go down by 1, and the n will get multiplied. So these two formulas you have to remember for integration and differentiation. Okay, the Zoom meeting will get cut in 10 minutes. You have to rejoin again. Is it okay?
Okay, sir.
Yeah.
Okay, sir.
So where was I? So using that thing, I can integrate this one. K is a constant. Another thing you have to remember is derivative of some constant, say number, into f of x with respect to x. This the number will come out. It's a times d by dx of f of x. Similarly, integral also integral of some function a into say f of x dx. That a will come out. Will be equal to a into integral of f of x dx. So this also is like a formula. This is a number, real number, should just come out. So here integral of k into x square, so k into x. So k is a number, so it will come out of the integral sign. And integral of x is x square by 2. Okay. So using that, I can get the potential stored in the spring as half kx square. So here we have a string with a mass attached to it. So I can have two types of motion. For example, let me assume. Okay, the string is fixed here, and the other end of the string there is a mass m. Okay, so this is going in a circular motion, and let me assume this is a horizontal plane. So the gravity force is say into the plane of the table. So this is the direction of gravity force. So the weight will be in the cross direction, and the normal reaction. So the direction of the weight will be cross, and the direction of normal force will be dot. So this normal direction balance is mg. But it's horizontal plane, the tension force will be like this. So this is the only force acting on this block. And there's an acceleration towards the center because there's a centripetal acceleration. That acceleration is AC. So if I write the Newton laws of motion, length force equal to mass into acceleration. So the net force is the inward force, that is the tension. That's equal to mass into the inward acceleration, that is centripetal acceleration. So which is m, and centripetal acceleration, we just have to use this v square by r. This one, this is centripetal acceleration v square by r, and it's equal to omega square into r. So from this, I get the tension as m into v square by r. So if m is given, and the velocity should be given. So from point to point, the velocity is constant because it's a horizontal plane. Velocity is same everywhere. So tension is same at any position of the string. This for horizontal motion, horizontal plane. But if you have the same string in the vertical plane, say the string is fixed at this point, and the mass is here, but the direction of gravity is vertically downwards. Okay, so here now the force is acting on this block. Mass is, what is the weight mg, and the upward force tension. Okay, and this is going in a circular motion. But here the circle of this velocity won't be uniform. The velocity here will decrease as I go up. Okay, but still I can write down, and there is a centripetal acceleration AC. So the net inward force is T, and the downward force is minus mg. Use the net force which is acting towards the center. So that's equal to mass into